What we're going to do now is we're just going to go over the summary of all the beam stuff, boundary conditions and what have you. Your problem is going to be in an exam situation getting confused between them. You have to understand, you can't be just learning off C1 is 0, that's not going to cut it. Now what's going to happen all the time, in any of the ones that we do, if you go through this, you're always going to end up with C2 is proportional to, now proportional means it's a multiple of, it's EI times the deflection, 0. Now all of our things have no deflection on the left. Simply supported has no deflection, fixed ends has no deflection, and cantilevered has no deflection. So this is going to mean why C2 is always going to be 0. The second one is C1 is related to the slope at 0. So for example, for simply supported, the slope, the deflection is getting smaller, is negative. I will draw a little picture of this in a moment. For fixed ends, it comes out straight, so C1 is 0. And for cantilevered, it comes out straight, and C1 is also 0. And you can also kind of solve these to see that, well, I won't say too much about them, but typically if you make E and I bigger, well, it doesn't really affect it. But say for simply supported, if you make E and I bigger, the deflection at 0 gets smaller. So when E and I gets bigger for simply supported, that slope gets smaller and closer to 0. Okay, so this explains why. Now we're just going to talk about C1 and C2 here. For simply supported, now we'll draw what the beam looks like if it's got a bit of load on it. Something like that. Now geometrically, with respect to the diagram, what does y of 0 represent? Well, it means how far are you off the neutral. Now the neutral is basically this. How far off this line? Basically the deflection. And y of 0 is how far are you off this line at 0? The answer is not at all. Y of 0 is deflection at x equal to 0, in other words the deflection here, and it's 0. So deflection has to be 0, so C2 is 0 also, for simply supported. And now y dashed of 0 represents the slope. Slope at x equal to 0. Now the question is the slope positive or negative? And the answer is the slope is negative. Down. So that means that C1, which is a positive multiple of a negative thing, plus by minus, C1 must be negative. And it's very important when you're doing simply supported that you get that your C1 is negative. If somehow you get your C1 as positive and you write down, I know this is wrong, C1 should be negative, I would like to see that in the exam and I will react well to that. Now, fixed ends and cantilevered, let's see what we can say about C1 and C2. It'll turn out that we can actually, now we'll just look at the left hand side and we won't worry about the right hand side. So, the beam is embedded into the wall. Now it can deflect after a while. Now it may or may not get fixed on the left, I don't necessarily care. What I do care about is that A, there is no deflection here. And B, the second thing is that the slope here is 0. It comes out straight. And it coming out straight means that the slope here is 0, which means that EI times the slope there is 0. But of course, EI times the slope at 0 is equal to C1. So C1 is equal to 0 for cantilevers and fixed ends. Okay, now you have a good summary of most of this stuff towards the back of your thing. I'm not sure it's a page 102, 103, I just seem to be looking at page 103. All your different equations, oh yeah, they're all here. 103 is a great summary. So So you just know point loads are deltas, uniformly distributed loads are U's, turned on with a plus and turned off with a minus, and linearly varying loads are lines, so there's just going to be y and mx plus c. And you need to know that your antiderivatives, you anti-differentiate a delta to a u to a square bracket, and square brackets anti-differentiate just like powers of x. Now, you also, as far as I'm concerned, need to kind of understand what's going on here. Now, the formulas that are important are this equal to that equal to that, and this equal to that. They will all be on the exam paper, so you don't actually have to learn them off or anything like that, but you should understand this, this picture, that you get from one to the next by anti-differentiating, and you always must pick up the constant. Now, typically we're calling this m double dash, which is fine. This is m dash, that's just a different way of doing it. This is y double dash to x, for example. You always must pick up a constant, and you always must pick up the correct one. So the first one is RA, then MA, then C1, and then C2. And the other thing to say is that even if your constants are 0, for example, for simply supported, these are 0. For fixed ends, for cantilevers, these are 0. I think it's a good idea to get in the habit of writing them, otherwise you might even forget the first one, which is never 0. Now, if you want a kind of a summary you're learning off, this table doesn't, I don't think it's something you should learn off, but maybe just if you understand this, you should be okay. So the first thing says this is the deflection at 0, and for all types of beams, there's no deflection on the left, so that means C2 is always equal to 0. Now, I have here the deflection on the right-hand side of the beam for simply supported. Doesn't really give you anything. So the deflection on the left of the simply supported beam is 0, so it doesn't give you anything. That's not actually true. Knowing that is equal to 0 actually gives you C1. And you will also know from this, now this isn't quite a boundary condition, it's just saying the slope is negative. You know that C1 must be negative. So you can find C1 knowing the deflection on the right is 0, and you also know it's negative. This doesn't really tell you anything, it's just saying for simply supported, the slope goes back to positive on the other side. You know the bending moment at 0 on simply supported, that gives you MA. And here it says that the bending moment at L, so the bending moment on the other side, is also 0. It says it tells you nothing, but actually that's not true. You can find RA out of that. And the last two conditions, probably not too important. This is basically more or less the shear at 0. And, well, actually I should probably just throw this one out actually for next year. It doesn't really add anything. Right. Now for fixed ends, what have we got? We've already discussed this one. Now, knowing that the deflection on the right of fixed ends is 0 will give you an equation RA and MA, and also knowing that the slope is 0 on the right will give you another equation of RA and MA. And if you have two equations and two unknowns, you can solve them to find RA and MA. And for fixed ends, the slope at 0 is equal to 0, so that means C1 is 0, and you have a similar story here for cantilever. Now also, because it's an anti-clockwise moment, the wall doing that, you will get MA is negative for fixed ends and cantilevered. Again, this actually does tell you something. I can't seem to remember what it is. Oh yeah, knowing the bending moment for a cantilever at the end is 0 allows you to find MA. So just be careful. C2 is 0 for all of them. C1 is 0 for fixed ends and cantilever, but not simply supported, where C1 is negative. And MA is 0 for simply supported only. It's negative for the other two. If you start confusing them, you will do very, very poorly in exam questions.